So hi everyone, I'm Sachin, final year IT undergrad at VJTI Mumbai. तो हम कर रहे थे नीट कोड 150 के क्वेश्चन. So let's get to question number 4, which is group anagrams. Let's see. So let's see the question. Given an array of strings strs, group the anagrams together. You can return the answer in any order. So let's try to understand what an anagram is. According to the given definition, an anagram is a word or phrase formed by rearranging the letters of a different word or phrase, using all the original letters exactly once. So what it says is, suppose we have a word ATE, it. It has one A, one T, one E. Then also ETA also has one E, one T, one A, which is anagram of ATE8. And we can also have TEA, which also has one A, one E, one T, and which is also anagram of ATE. All these three words are anagrams of each other. And similarly, we can have more anagrams like TAE and so on, right? So these are anagrams. In order to solve this question, let's try to understand the question. What it says is we are given strings strs, and then we have to group all the anagrams together. Like from the question we can see we have bat, and it does not have any anagram in this strs string as we can see. So bat is alone, and then we have nat, which has its anagram as CAN. These two are grouped together. And also then we have ATE8, EAT8, and TEAT. These three are anagrams of each other. These three are grouped together. So we have to pick a word and then group all the anagrams together, right? So how can we solve this? The most basic and brute force approach someone can think of is he can just take the word and he'll sort the word. Like for example, let's take these three words EAT, TEA, and ATE, right? We will just sort these, and EAT will get converted to AET, TEA will get converted to AET. Why is that so? Because A comes first, then comes E, then comes T. ASCII value of A is smaller than E, which is smaller than T. So if we sort these three words, they will be sorted into same word, and we'll just group all the words together whose sorted words are equal. Like here we can see all these three words have common sorted word as AET. These three will be grouped together, right? So this is the brute force. Let's try to code it. So what we can do is we can just use a for loop, and we'll pick one word at a time, and then we'll traverse the all the words ahead of it, and all the words ahead of it which are its anagram will be grouped together, right? So let's try to code it. For int I equal to 0, I smaller than strs dot size I plus plus. First we'll make a bool function named is anagram. In order to check if two words are anagrams of each other, we'll take string A, string B. We'll take two strings as its input. We'll just sort them first. And we'll just return if A equal to B. See, we take two strings as input, string A and string B. We just sort those two strings, and if the sorted strings are equal, then these are anagrams of each other. If they are not, then they are not anagrams of each other, right? So we made a function, Boolean function, to check if given two strings are anagrams of each other. We'll make a Boolean vector of name repeat. So what will this do is, in order to prevent repeating the words, we are using Boolean vector repeat, and we'll just assign all the values as false for the Boolean vector. I made a Boolean vector of this same size and then assigned a false value to all the indices. So if I use this first word EAT eat, we have its anagram as T EE8T and also ATE. So when I include these three EAT, EEA and ATE in one group, I'll just mark them as true, right? So next time when I get to these words, I will not include this in my answer. So let's continue. If strs of I equal to false, first we make a vector string group. So in order to include these groups in the vector in, we need to return the answer in the form of vector string. I'll just give this name answer. We need to return the answer in the form of vector of strings. So I just initialized the answer, and also in the for loop we will group strings together, right? So we'll need a vector string of I just gave it a name group. All right. So if the string is not included in the answer, then what do we do? Group dot pushback strs of I and then j plus plus. So we'll just check if the given two words are anagrams of each other. So we have made a function is anagram to check if the given two strings are anagrams of each other. So we'll use it is anagram. We use first string strs of I and then we take the second string input as strs of j. We check if they are anagrams of each other. And if they are anagrams of each other, we just include the strs of j in the group. And also we mark as repeat of I equal to true. Ith index we have used here, we have included in the group, which would be included in the answer. So we'll just mark repeat of I as true and also repeat of j as true after the for loop. Yes, it's working now. So what did we do is, I'll just check if it's getting accepted. Time limit exceeded as expected. Answer was correct, but it takes a lot of time, so hence time limit got exceeded. I'll just explain what did we do. We made a bool function in order to check if the strings are anagrams. Then we declared a vector of bool of repeat in order to check, in order to keep a check that we don't use the repeated words, right? And then if the word was not repeated, then we would make a vector string of group in which we would include all the strings which were anagrams. So we would check if two strings are anagrams of each other, and if they were, we would include them in the group and we would make that index as true. Whichever word was included, whichever string was included, its index would be made true. And then after the for loop, we push that group into our vector string of answer, right? We push that group into our answer. And after we get through all the strings, then we return the answer. So what's the time complexity and space complexity? Let's get to it. What is the time complexity? We sort each comparison. So we sort eat, we sort t, we sort tan, right? Each string is sorted. So if the size of the string was k, then the time required for sorting it is k log k. And also we have two nested for loops. We have here a for loop and we have here another for loop. And inside that we use is anagram, which uses sorting of the strings. Essentially, the time complexity becomes as big of n square into k log k, which is really high time complexity. And if we talk about space complexity, the space complexity essentially is big of n. Why is that so? Because the only the extra space we are using is we are declaring vector bool repeat of strs dot size, right? Let's get to the optimal approach. So, what would be an optimal approach? What we can do is we can essentially take a word as key. Suppose we take it and we include all the anagrams of it in that group, particular group, ATE, EAT, TEA. Similarly, we go on in the array. So suppose we have this array, complete array, then the word is EAT, eat. We sort it, we get AET, and then map AET into EAT, right? Then we have word TEA, which is sorted AET, which is also mapped to given AET, and we include EAT and TEA in AET. Similar goes to tan. Tan is different from EET. It sorted becomes A and T, and tan is mapped to A and T. Similarly, we can go on. The mappings will be done, and the final output will look something like this, right? All the strings which are anagrams of each other would be included in one place, right? Essentially, what we can do is we declare an unordered map, and let's give it name as UMP, right? And after that, for int I equal to 0, right? String s is equal to strs of I, and then we'll just sort s, and then we'll just map that given string to s. UMP of s dot push back strs of I. And after that, we will include all the strings which were mapped to given string. We'll include this vector into the final answer, this vector into the final answer, this vector into final answer, right? So we'll do that for, right? We'll just first declare our answer, vector string of answer, and in that answer we'll include answer dot push back it ka second. So what was first? It's first was the given string, and it second was the vector which was mapped to the string, right? And we want the vector which was mapped to that given string, right? So we are including the it iterator ka second part, and then we'll just return the answer. Let's see if it's getting accepted. Okay, I was supposed to comment this answer, comment out this answer. Let's see if our answer is getting accepted. Yes, it is getting accepted. Submit the code, and yes, it's getting submitted. So this was the optimal approach which solution is getting submitted. I'll just recap what we did. We declared an unordered map of string and vector string in the name of UMP unordered map, and then I declared vector string of answer, which would be our answer having all the group of vectors, and each vector would be having all the words which are anagrams of each other. Then we iterated through the loop through the complete vector strs, and then we declared a string s which would be equal to strs of I, and we sorted that s. Why did we do so? So that s would be the key which would be used to map all the strings which are anagrams of s. And then we iterated through the complete hash map and included all the vectors which were there to our answer. And this is how we got the optimal solution. So essentially, what would be the time complexity of our approach? We have used one for loop, and after that we have used another for loop. So this would be big of n, and in that we are using a string s, which suppose its size is k, and we are sorting that string. So it would be k log k, and we have essentially the time complexity as n into k log k, n into k log k time complexity. And what would be the space complexity? We are using one for loop, so big of n, and inside that we are using string s of k size, right? So it would be n into k. So that was our solution. See you in the next video.